Hello, in this video we're going to look at exciting and potentially disruptive technologies. We will investigate how solar energy can be used both directly and indirectly to produce hydrogen. We will examine the wheels that are being set in motion to produce clean hydrogen for just $1 per kilogram in the next 10 years. Do watch this video till the end as it has some really interesting information. Together, let's explore the possibilities that arise when diverse ideas synergize. I'm Harun Junedi, and this is Synergy Files. Hydrogen, and in particular green hydrogen, has been deemed as the ultimate clean energy. However, extracting hydrogen is energy intensive, so the source and the method of its extraction are both important. Green hydrogen, abbreviated as GH2, is hydrogen generated by renewable energy or from low-carbon power. At present, about 96% of the world's hydrogen comes from coal and gas, which are categorized as brown and gray hydrogen, respectively. The remaining 4% is created from nuclear and renewable resources like hydro, wind, and solar. The production of both gray and brown hydrogen releases carbon dioxide and unburned methane into the atmosphere. This superpolluting hydrogen is what's currently used as the chemical base for synthetic nitrogen fertilizers, plastics, and steel, among other industries. This shows that hydrogen is already being used in large quantities, that is 95 metric ton in 2022, which is a 3% rise compared to 2021. At present, very little hydrogen is being used in the transportation sector. The transportation technologies, however, are rapidly moving towards the use of hydrogen both through hydrogen internal combustion engine and hydrogen fuel cell. Therefore, there is a huge scope for producing clean hydrogen. The benefits of moving towards hydrogen as a fuel are obvious. Not only it's a cleaner solution that will be able to meet most government legislations, but also has a much higher energy density compared to existing batteries. The disadvantage of hydrogen is its high price. It is about $5 to $7 per kilogram in the US and $7 to $11 in Europe and Australia. Furthermore, as mentioned earlier, the way hydrogen is largely produced today, that is methane reforming, also releases carbon dioxide as a byproduct. This is unacceptable if hydrogen is to be used as a green fuel. It is for this reason that researchers are avidly looking to bring down the costs through the use of renewable energy and novel techniques. There are multiple ways in which water can be split to produce hydrogen. These are electrolysis, photoelectrochemical water splitting, photocatalytic water splitting, radiolysis, photobiological water splitting, thermal decomposition of water, nuclear thermal, and chemical production. In this video, we will limit ourselves to the methods that can incorporate solar energy to produce hydrogen. At present, the green hydrogen that we know about mainly comes from electrolysis. This process can be fairly inefficient. The best electrolyzers are around 75% in efficiency. And even with the best electrolyzers, if we factor in the electricity from solar PV, which is around 18 to 20% efficient, then the overall efficiency drops to 15% at most. Recently, an organization called Solhide has produced solar panels that give the output of hydrogen instead of electricity. The way the panel works is very simple. It uses solar PV panel in the top layer to generate electricity. This electricity is then used in an electrolyzer that sits underneath the top layer and produces hydrogen. So the Solhide panel is just a PV panel with an electrolyzer attached. The clever bit is that the panel recovers water from the moisture inside of air, so there's no water supply needed. This technology is called direct air electrolysis. The moisture captured from the air is soaked up by a sponge-like material, that is, melamine sponge and sintered glass foam. The sponge-like materials are soaked with a deliquescent ionic substance which helps to absorb water from the air. The soaked sponge also acts like an electrolyte. By tapping water from the air, This panel takes care of an important concern, that is, it does not use fresh water from existing resources. Note that fresh water is running out, and if hydrogen is to be produced at a large scale, then using a resource that is already getting scarce does not make sense. The Sol height panels, in terms of process efficiency, do not give any advantage but still give a respectable 15% overall value, which is healthy if you look at hydrogen produced by electrolysis. Having said that, there are new techniques of electrolysis that have recorded 95% efficiency. Hysata, an Australian company, has developed a patented capillary-fed electrolysis system. This system gets rid of the gas bubbles that start to accumulate around the electrodes with the onset of electrolysis. These gas bubbles are known to reduce the efficiency. Instead of dipping the electrode completely in water, they replace it with a capillary-like method. The electrolyte is continuously sucked up towards the electrode by a porous hydrophilic interelectrode separator. By mimicking the way plants absorb water, the hydrogen and oxygen molecules can be split without forming bubbles in liquid. According to Hysata, this will reduce the cost of producing green hydrogen to well below $2 a kilogram, making it cost competitive with fossil fuels. Green hydrogen nonetheless will be at most 18 to 19% efficient even with the capillary-fed electrolyzer if solar energy is used to produce electricity for electrolysis. It is for this reason that producing hydrogen directly from solar power without the intermediate step of electrolysis has been the subject of research for many years, but so far the technology hasn't got a commercial breakthrough yet. Having said that, there are a few developments on the horizon that can be a game changer. First is water splitting using photoelectrochemical cells. A photoelectrochemical cell uses specialized semiconductors that can split different molecules by directly using sunlight. We first mentioned photoelectrochemical cells in a video on recycling plastics. They are being looked at to convert carbon dioxide and plastic into fuel, like syngas. Likewise, they're also being tested to split water into hydrogen and oxygen. This is one of the most promising technologies for hydrogen production, thanks to perovskite. Using monolithic stacked silicon perovskite cells, solar to hydrogen conversion efficiency of 20.8% has already been achieved. This is a huge leap from efficiency of just 0.1% 10 years ago. The next technology that is worth mentioning is the photocatalytic water splitting. So far, the solar to hydrogen efficiency using this technology is comparatively low. Using indium gallium nitride photocatalyst, a peak efficiency of 9.2% has been achieved. However, this technology can be scaled up fairly easily. Therefore, this remains an important renewable energy strategy. Another technology that is worth mentioning is solar thermochemical water splitting. A simple explanation of this method of water splitting is that a metal oxide is heated to a very high temperature. This results in a reduction reaction. The hot metal is then brought in contact with water. The oxygen is taken out by the metal from water and hydrogen is liberated. There are over 300 different water splitting cycles that have been studied with different metal oxides and catalysts. Some require temperatures of 800 degrees centigrade while others as high as 2000 degrees centigrade. For reaching these high temperatures, concentrated solar power will be used. It has been researched that efficiencies of up to 59% can be achieved. The major impediment in this technology is the cost of heliostats. Now, there are other technologies on the horizon too, like photobiological water splitting, but so far very low efficiencies have been achieved. Hydrogen from solar is an exciting area of research, just like solar cells have been for over a decade. The goal for reaching $1 per kilogram of hydrogen is still distant, but there is progress on multiple fronts. We will keep you posted with the latest developments in this field. Subscribe to the channel if you haven't done so. If you learned something from this video, then please do consider giving it a thumbs up. Thank you for your attention.